Good morning. My name is Kevin Madden. I work for Telefónica Tech. I'm a solution architect there. So what we're going to talk about today is basically the partnership and work that we've been doing with InterSystems for the NHS Trust, and with our aim being to provide supportable and reliable integration engines. I'm going to talk a wee bit about Telefónica Tech and our work in the health service. And then we're going to focus on the work that we've done in one of the trusts, which is Cambridge University, and how we've brought their integration engine architecture on a journey to give them a reliable and supportable system. Telefónica Tech, big global company. We've got about 4,000 professionals around the world. In UK and Ireland, we've got 11 locations, so we've got about 1,000 FTEs covering the spread of the Isles. From a healthcare technology expertise, we do work on nearly 50 NHS clients. 33 of these we do managed service work, so quite a big spread of work that we do. And as I mentioned today, we're going to focus specifically on Cambridge University Hospital. Cambridge University Hospital is one of the global digital exemplars. So this was an initiative set up by NHS to digitally transform trusts. So Cambridge is one of those. So it's a big hospital, 1,200 plus beds. They've got 18,000 staff. Physically, it's spread around a big area as well, and obviously it's got a university part to the hospital. CUH, for them to provide a centralized patient information system, they've made it up of, they have an electronic patient record system, which is Epic. They have a trust integration engine, which is based on InterSystems. And they have an instrument management integration engine, which is based on data innovation software. All of these here at the underlying and the core database is an InterSystems database. So we're using Epic InterSystems. This here shows a sort of high-level view of the architecture, the integration architecture within CUH. At the top here, you can sort of see that on the left, this is our electronic patient record system. It integrates, the big integration into it is via the Trust integration engine, and that's based on our InterSystems system. You can sort of see it, we connect to loads of different disparate systems integrated into that. One of them being the instrument manager system, which again connects all the analyzers and things in the hospital, which then feeds into the Trust integration engine, which then feeds into Epic. From an Epic perspective, Epic's the electronic patient record system, so this is the single truth for a patient. It also provides the whole reporting side of things for all the regularity type reports that have to go up to the NHS. Big part of the solution is the sharing of information. It's us sharing our information with all the trusts accessing our information. Big lot of sharing information. We also connect into NHS Spine for things like newborn babies, getting information for looking up addresses, getting valid addresses and things, and for bookings and things to do with GP appointments. We are also doing a lot of work with artificial intelligence systems now. Again, the aim being giving the customer that best solution, or the patient the best solution for what they need for the treatment. And we're also doing work with RPA virtual workers, so we've brought in robots to help with repetitive type tasks that medical secretaries might do. We're sort of using robots for that purpose. So at the core of this here, we have got the operational database is Iris-based. So again, this is the whole system, database system. This here shows you a bit high level detail, but it shows you on the left our primary data center, our secondary data center, all based on Iris databases. We do journaling, Iris or InterSystems journaling from production to reporting, and that gives us the whole base for the reporting system. We also journal data over to the secondary data center for our production and for our production reporting. So again, giving us a whole data center failover capability. Also in the primary data center, we have a lot of other non-production environments, support environments, training environments, all based on Iris. For our trust integration engine, which is provided by InterSystems, you can sort of see here, it allows us to have to standardize the data flow between all these disparate data systems. It gives us a standard way of developing the workflows. It gives us a flexible way of developing. It speeds up the way we develop. And ultimately, it reduces the total cost of ownership of developing these integrations because we're using a standardized approach. One of the integrations that we integrate with is the Data Innovations Instrument Management System, and it's a lab management system. And again, it integrates with all the analyzers in the hospital. Standardized approach, standardized field. We bring on you. It's all done in a very standard way. This information all flows from Epic down into trust integration into the data innovation system and back again. Underlying all these is the InterSystems database platform. So looking at the journey, so we're going to look at specifically the trust integration engine and the lab system. We started with the legacy systems were pretty old. There was 2008 servers. There was no real high availability. There was no real BCDR of worth, but they did have a common architecture. And then our goals moving forward was to put in a new hosting platform, new operating system version, and make high availability and business continuity sort of key to what we were delivering. And again, to keep a common architecture. So stuck with InterSystems for the trust integration and data innovations for the instrument manager. This diagram sort of shows on the left, the diagram, we've got a common architecture which covers the trust integration and the instrument management. The trust integration is using Iris, the data innovation is still using Cache, but it's the same sort of architecture that we're both used for both solutions. On the left there, you can sort of see this is our mirror. We've got two members in the mirror, both hosted on different hosts, both running an Iris database. We use a synchronization link to keep the primary failover member and the secondary failover member in sync. So the secondary failover member is always there ready for us if we have to failover. So we get a problem with the primary failover, we move it over to the second. And then on the secondary data side, we keep an asynchronous member, which we then can be used to replicate the data to it. So if we lose the primary data center, we can fail over to the secondary data center. We use a VIP basically to point to the mirror, so the VIP doesn't care which of the members is primary. We use on the members, we use an ICSA agent, and basically what that does, the backup member sort of keeps an eye on the primary member to see, are you still there? Can I contact you? And if it can't, it starts to think, well, am I in a failover situation? Has something happened to my primary? So I would automatically fail over. We also use an arbiter server, which is, again, physically on a different host, and it makes connections to the primary and the secondary members. And again, so between the arbiter and the connections from the backup member to the primary, it sort of says, have we lost the primary? And if we have lost the primary, then we ought to automatically fail over to the secondary system. So if we look at sort of, an external system coming in, it connects to the VIP. It doesn't care which is the primary, the failover member 1 or failover 2. Then in this example here, the failover server 1 is the primary, so it'll connect back out to the external systems. But if we failed over, then the secondary will come out. On a very practical note, from a patching perspective, all the zero-day patching and stuff that happens at the minute, we use this mechanism here for doing our patching. So we would patch our secondary member, fail over to it, and then patch the other. And when we do this, zero-day patching, we do this patch at least once a month, and we do it at 4 o'clock on an afternoon. It's not, it's not the busiest integration time of the day, but it's required integration time. But we can still do it when integrations are happening without any sort of loss of data. The challenges that we found, like all these systems, lots of integrations, lots of third parties, not so much documentation. So there's a lot of reverse engineering going on there in terms of understanding what was there. The challenges, I suppose, talking to get in contact with the third parties and things, they were all using connecting via host name and IP addresses. So there was that sort of a hard coding dependency. They weren't using the LDAP. Some of them didn't have test systems as well, which has made it difficult for test purposes. From an upgrade transition approach, we worked very closely with the vendors, with InterSystems and Data Innovations on our architecture, on our approach. We work closely with the third parties as well in terms of testing this in advance. We come up with a phased cutover approach, like a pre-cutover and a cutover and a post-cutover. The idea being for the cutover, we just to minimize the downtime. So we worked with them in the pre-cutover. What we did was we introduced, for example, the CNAME concept. So we used like a DNS CNAME to point to the legacy systems. And we've done that. So that meant whenever the cutover, we could just repoint the CNAMEs to our new platform. So we did a lot of this work up front. With the third parties, we did a lot of connectivity tests. We come up with a pro forma how to test. Connectivity tests, could they use CNAMEs? And if they could use CNAMEs, could we move it in advance? So it meant then when we got their cutover night, we had a very limited sort of outage window. From a lessons learned, a lot of what was said there, working with the vendors, working with the third parties, doing our pre-cutover, doing our post-cutover, minimizing our downtime windows, and basically a lot of testing. One of the things we did find, from an architecture perspective, I've shown there our high availability where we've got our primary and our secondary and our arbiter. We found whenever we went live that some nights it was failing over, when we weren't expecting. It was a wee bit too temperamental. We looked at it and we looked at the overnight schedule and we sort of realized that there were some overnight jobs and there were some backup jobs sort of happening maybe in sync. So we basically just rescheduled our overnight to make it sort of staggered, and we've had no real problems ever since. How we provide support, we provide 24/7 support. We have a trained team that look after all this here. We have got monitoring and alerting enabled and set up, so the flags us all. And basically, we manage to get it and close working with our vendors and stuff. So in summary, I said before, core to this here is a central patient record, electronic patient record system, trust integration, instrument management allows for maintaining us here. Our core principle, and working with the trust is patient care, and we believe the architecture, what we've put in, helps that there because there's no outages, no unavailability, and it's continuous use. So, thank you, and any questions?